Hi everyone. Today our topic is moving towards implementation. This is the last stage in every system analysis and design process. If you look at the process, we started from planning, then analysis, then design, and now is the implementation phase. So in the implementation phase, we actually apply what we have planned, what we have designed, and what we have all the DFDs and the use case scenario and the use cases and the ERD. So meaning to say in all the earlier phases, what we have designed, we will just implement that one in this phase. Okay, so we will cover that how to manage the process, and the main thing is the testing and the documentation. Okay, so the implementation phase consists of defining and testing system software, developing and testing system software. So you see there are two components. One is development and one is testing. And the third component is documentation. So these are the three major components in implementation. Managing the programming process is the major task for the system analyst. So in this case, the system analyst is taking care of the programming, that what type of programmer to hire, how to implement, which language to use, which programming tools to be used. Okay. So while programmers work on the programming, the system analysts design a variety of tests. So you see on the one side, the programmers are developing the system, but the system analysts who have programming background also and a business background also. So who he is designing several tests that later on will be just applied by the system, and the system will be tested by that. And during this phase, the system analyst finalize the system documentation also. So the system analysts actually have this major role that how to control overall process and design different tests and to make sure a very nice documentation. So a project manager's task during the process of programming. So meaning to say that the system analyst will actually assign the development task to different project managers. If the system is very complex, then maybe several project managers. If the system is not complex, then maybe one program manager, and it may be one of the programmer in the programmer's team, and it has been assigning programming tasks and coordinating the activities and managing the program schedule. So the project manager do these tasks that assign different programming tasks to different programmers. That let's suppose you will develop databases, you will develop interface, and you will develop this aspect and this aspect. So they just assign to each other, and after that they are coordinating the activities, meaning to say actually in a system, one part of the system depends on the other part of the system. So some programmers may need something from other programmers, so there should be a very nice and friendly coordination among them. Otherwise, if they are not coordinating with each other, then the overall progress will be effective. And a project manager first groups together modules. You see, yeah, if the system is composed of various modules, so the project manager actually group together different modules. That let's suppose module 1 and 2 and 3, these are interrelated, and it is, let's suppose, all related to database. So a person who have good experience in databases, the project manager will assign to that person. And another modules will be assigned to another one. So in this way, the project manager assign different modules to different programmers. And during the coordination can be done through both high-tech and low-tech means. The simplest approach is to have weekly projects. You see, means you see the coordination that every week they should have a meeting and they share the problems, the achievements, and maybe some progress that they have done. mm, for the week. So everything, if they have every week a meeting, then actually the project manager, the system analyst know on time what is the progress, what are the challenges, and what are the problems that we are facing. Another important method is to create and follow standards. So there are many standards. Okay, we just pick up maybe one and follow it. And many project teams set up three areas. For example, development area, testing area, and production area. So you see, there is again a different teams are possible. The development team will work in development area, testing team, and the production uh, and implement change control techniques, keeping files and programs in different places according to the completion status and using a program log. So it means that whatever they complete, let's suppose some modules are completed, then they keep in one specific applications and they keep a program log for them. That program log is actually like a history type of file which maintain what they have done and when they have done and if that work is done by who. So all these things are maintained properly. And how to manage the schedule? Actually, schedule is a very challenging task in system development. And most of the time, we cannot cover we cannot develop the system at the given schedule. Most of the times, we need more time than the estimated time that we start at the beginning. So the initial time estimated must be refined as the project progress during the construction. And one of the most common causes of schedule problem is scope creeping. Creeping means that let's suppose previously the system was composed of four modules. Okay, so the scope was about four major components. But later on, during the analysis or during the design phase, the scope become bigger. Okay, so when the scope become bigger, then actually the planning and the design analysis was for modules. But later on, let's suppose it became six or eight. So you see, the scope become bigger. So bigger scope means bigger functionality, and bigger functionality, many functionality means it will need more time. It will take more time to develop, more time for documentation, and more time for testing. So in this way, the schedule changes, and this is one way. One cause the schedule we cannot provide the system in the given time. Another reason is that every day the day-to-day slippages. For example, if the programmer has a target that okay today we will complete module A, but actually they couldn't complete. Okay, so the next day. So meaning to say, every day they couldn't complete something. So that slippage become one time a big thing. And as a result, the schedule they couldn't provide on the given schedule. So there are different classical implementation mistakes. For example, number one, a research-oriented development and using low-cost personnel and lack of code control and inadequate testing. So these are the common mistakes. Like research-oriented development, for example, if you are going and keep researching and keep researching, so actually, if you are keep researching for the new trends or maybe for the new things. So the research never ends. Okay, so this is also one mistake. Another mistake is that when you are hiring people for development, then at that time you hire low cost people. So low cost people means that they have no experience, no coding experience, programming experience. So of course, if they have no experience and they don't know too much about the system and maybe the overall development process, so the quality will be low and they couldn't deliver on time. So this is also one mistake. And lack of code control. Code control nowadays we are using the GitHub and Git for that. Code control means that once you have one version and another version and another version, and for example, one user have one version of one module, another different user have a different version of the same module. So all these things should be properly managed. If you don't manage, actually it will create issues for you. And in adequate testing, if you don't have proper testing, then this is also a big mistake. Actually, testing is the very critical task in every system. For example, if you look at this table, this much amount has been this much amount has been vested by many companies. For example, you see each company vested this much money and the other this much money. So a lot of money, billions and millions of money vested only because if the system was not properly tested. If the system was delivered and it was not properly tested. So the companies face that much loss because of that. So it means before releasing a system, you should thoroughly test from different perspectives, and we will cover that. Okay, so test planning, testing starts with a tester development testing plan that defines a series of tests. So there should be a proper plan which contains all the tests that you will have to do. And a test plan describes a set of very specific test cases to be examined. So there are many cases are designed. Test cases means, for example, if someone is logging and they have if someone is logging and so he or she forgot password. So this is one case. So how to deal with it? So if forgot username. So how to deal with that? How to recover the password? This is another case. So you will start from beginning of the system until the end of the functionality and will create different possibilities and each possibility become a test. Okay. So all these tests you will have to check. So then again, there are four stages. For example, unit test, integration test, and system test, and acceptance test. We will talk about this. So you should test the system from all these four perspectives. Okay, so and every test, you see, every test should have these like details, the program ID and the version ID, which version you are going to test, who is testing it, and what was the date and the test conduction date, okay, and the test ID and the test requirement address, and you see the interface ID, data fields. For example, the test that you are going to conduct, what data fields are involved in that, and what values you entered, what are the expected values and what you entered. So what was the expected result and what you get the actual result. So all these things, you see, for a single test you will have to maintain that much information. So if you thoroughly check the system like this, then it will be error free. And you see the professional system, for example, Microsoft Word, okay, and Microsoft Excel and Windows system. So we are using and we are not getting any such mistake or such error, okay, that there is no help for that or no documentation for that. Okay, so each module or each activity is actually a case. For example, this is one case, create a new item. So you will have to test this functionality from different perspective. Okay, that a user is creating, admin is creating, and maybe from different perspective, from low internet, high internet, from mobile version, computer version. So there are many possibilities. So each of these will, is an example of one case. And you see the error curve, that most of the errors comes during integration testing. So what is integration testing? We will talk about that. Unit testing, integration testing, and system testing, and acceptance testing. So these are the list of unit testing. We will talk about this. Like unit testing focus on one unit only. Okay, a program or a program module that perform a specific functionality. For example, if we think about ELEAP, so ELEAP has many different functionality. For example, it has a quizzes, it has a term 18 assignment, it has a normal assignment, it has a MCQ section, it has so many different functionality it has. So unit testing means that you go and check individual functionality individually. Let's suppose the MCQs or the quiz part. So you check that section from different perspective. You give different quizzes, having less question, having more question, having less option, more options. So individually check that functionality. Each functionality of the system is called unit testing. And that unit testing, again, there are two perspectives. One is black box testing. Black box testing means that you don't know. You consider the module as a black box. Black box means that you don't know what is the coding behind it, what type of language has been used. Okay, so you don't think about the coding, you don't think about from the programming perspective. That is a black box for you, but you are testing functionality wise. This is one way. Another way is white box testing. In that case, the tester reviews the actual program code. Actually, the tester go and check the coding. Okay, and then from the coding perspective, they are checking. Okay, so these are the different possibility. After that is integration test. Integration testing means that you have, let's suppose, one module and second module. So let when you combine these two into a one system, so they integrate together. So then check again. So you see at this time is actually very critical. And if you look at the graph on the previous slide, so majority of the errors comes here. Meaning to say that the units, the modules are working very nice when they are separate from each other. But when they are integrated to each other, then create problem. Maybe one module cannot provide proper values to the other, and maybe the other one is expecting one type of value and getting another type of value. So these are the different possibilities. So like there are four approaches to integrate to integration testing, like user interface testing. Okay, when you combine different modules into one system and create a user interface for that, and then you are testing. Or use scenario testing. You think about one scenario. Okay, that let's suppose the person is trying to register, okay, and provide less information. Okay, this is one scenario, and someone provide more information also. There are many possibilities. And from data flow testing perspective, system interface testing. So these are different levels and ways how to test the system during integration time. System testings are usually conducted by the system analyst to ensure that all the modules in the program work together without error. So system error means now after integration, all the modules are integrated into one complete system. And after that, the whole system is analyzed and tested. So system test examines how well the system meets the business requirements. So then it will be tested from usability point of view, from security point of view, and from performance point of view. Okay, and the performance may be when it will be tested by many users together, and by meaning to say by heavy load and by less load. And the last thing is the system documentation. That is also very, very important. Then the system analyst will make sure that all these things will be documented. Okay, if not documented, then later on they can document it. The last type of testing is acceptance testing. Acceptance tests are done primarily by users. Okay, it is not by the system analyst anymore and not by the programmer anymore. Okay, they give to the user and tell them, okay, you test now, because the user don't know the programming background and the proper way how to enter values. So meaning to say you give the system to actual user. Okay, then let's see how it behaves now. So the goal of acceptance test is to confirm that the system is complete and meets the business needs and is acceptable to the user. So if when the user tests it and it is working for the user, there is no errors in that, and the user like the messages, the way to enter data, the way the system generate reports. Okay, all every aspect when the user like it and the user says that okay, it is meaning to say it is accepted by the user, then will be really a great job. So this is the acceptance testing. In acceptance testing, there are again two phases. One is called alpha testing. In alpha testing, the user tests the system using made up data. Made up data meaning to say it is dummy data. It is not actual data. Okay, by dummy and non-actual data, they test the system. But in beta testing, the user actually tests the system by real data, okay? And by real data, for example, for example, if there is a purchasing of product and then putting in the card and uh, the payment process. For example, any type of system, they put in a real scenario and then test it. Okay, next component is system documentation. So there are two types of documentation. One is system documentation and one is user documentation. In system documentation, the programmer and the system analyst try to understand the system and enable them to build and maintain it. Meaning to say they write the documentation in such a way that later on if someone read this documentation that they will understand how the system was developed and then how to modify and how to maintain further. Meaning to say this is a technical type of documentation. And user documentation is simple one that is just about how to use it. Okay, like a manual. And user documentation should not be left until the end of the project. Yeah. So meaning to say once a module is completed, there must be a documentation up there. If you left it till the end of the project, then later on you cannot go back. Okay, maybe you already forgot many things about the early developed modules. So it should not be left to the end of the project. So meaning to say documentation, development, and the testing should go parallel with each other. And there are four key strengths for, okay, there are different ways of documentation. You can do the documentation manual in a hard copy, you can do the documentation online also. So nowadays the majority trend is online. They put the documentation online. So these are the four key strengths for online documentation. That searching for information is simpler, and the same information can be presented in many different formats because it is available online, and it enables the user to interact with the documentation in many new ways, and it is significantly less expensive. Yeah, because it doesn't involve any papers. And there are three fundamental different types of user documentation. From user point of view, there are these three types. One is reference documents. The reference documents are designed to use when the user need to learn how to perform a specific function. Actually, a reference are the technical functionality of the system. For example, if you want to learn, let's suppose you are going to learn a language. So if you go to the reference module, okay, there you will see all the details of each and every function. The function need what type of argument, it will return what, and how to do, how to call with examples. So reference document is the system functionality mm, detailed document, that how the system works, and actually most of the programmers refer to reference document. Procedural manual describe how the program how the system perform a business task. So you see here is about like a manual. The previous one reference is like a technical document, that how the system will perform a business task. And the last one is a tutorial for normal people. They teach the people how to use major components of the system. Okay, so these are the three very important documentation types. The general structure used in documentation in online documentation is to develop a set of documentation navigation controls. It's just the way how if someone is reading the documentation, so how to read it. So of course there will be different type of navigation control. For example, table of contents or index, text cell, or intelligent agent, or web-like links. So web-like links. So it is look like this. For example, you see these are the table content and then the index. So if you click on it, so it will provide different links. Okay. Writing documents, documentation topics. So topic starts with clear title. Yes, when you are writing documentation, so you will use clear titles, then followed by introductory text that define the topic, and then provide detailed step-by-step instruction. So meaning to say title, clear title, and a bit introduction of the title, and then detailed step-by-step procedure of that modeling. And many topics includes screen images. Sometimes maybe we need to include screenshots also. And most also include navigation controls to enable movement among the topics. And some also have links related to that. Yeah. So meaning to say, if you are explaining something and maybe this topic is related to some other topic also, then maybe you can provide a link. Like this one, you see, if you search something, you will get a lot of, this is Windows search and Windows help system. So it will provide that much help, but still, if you want further one, so you see here, it is going to be with other topics. These are different guidelines, how, what type of language and what type of grammar, what type of wordings you should use when you are writing a documentation. Okay, and navigation terms are used to help user find topics. When a user are searching for in the documentation, then the terms used in the navigation, maybe the terms used in the interface, okay, or maybe the major functionality words are used for navigation purpose. So the user are searching for the keywords. So it should must be included in the documentation process. So this is a brief introduction to the implementation